Okay, so for the homework, what you're going to do is just hold on to it. For the next, we're just going to introduce graphing calculator and how to work that, and then the next topic we're going to go on to is constant rate of change. So when we get there, that's when we'll hand that in. I'll give you warning, okay? So don't throw it away. You will turn that in, just not today. Okay? So go ahead and get your laptop out if you got it, and we got to make sure that everybody can see a screen. So some people don't have graphing calculators. So you find someone to pair up with if you don't. Anyone need a buddy? Anyone can't see a screen? Don't be shy. Everyone's good? Okay, the first thing I want to show you with graphing calculator is it's just like an old school calculator. It'll do just standard computations for you. So when you open up the program, you should see this. This is a display window, and then up there's a little purple box. That's a command line, okay, command line. And so it should just come up with a window with a command line. And so you can just type in 3 plus 5. You don't even have to enter. And when you do that, let me make that a little bigger. When you do that, you should see the answer. And so I can alter this computation, and just on the fly, it'll keep updating the answer. So I can go -7 divided by 4. And so every time I update it, it just keeps giving me the current value of the expression. Okay? So let's just do a little exercise here to practice that. So suppose I have a trapezoid. Okay, and then this really is a circle. Oh, much better than the first class. Okay, yeah, that's pretty good. All right. If I don't say so myself. They just had to take my word for it in the first class. All right, so let's say this is a trapezoid with a circle cut out of it. So we got, say, 27.3 down here. And then, I don't know, 14.8 and 19.63. Okay, so the goal here is to write one command. So to get a new command line, so if you hit enter right now, just nothing will happen. To get a new command line, you're going to do on Mac, it'll be option return. We'll start a new command line. And on your PC, it's control return. So you see, it gives you a new command line. So the goal here is on one command line to type in an expression of values that will calculate the area of the shaded region. Okay, work together. So, and you want to put it all on the same line. So calculate, so you're writing an expression just like the one above, but that expression then will calculate the area of the shaded region. Work together, go. Now let's do 14.8. 3.
Base 1 plus base 2 divided by that. Well, we know its radius is half.
I changed the height. 14.13. I changed the height.
Yep. I'm retarded.
Try closing it and reopening it first.
Which one's mine? I think we use frequent ones.
Okay. So yeah, you're gonna need to reinstall and use the new. Back to the.
Just make sure we have
Use this new registration. So if you use the old one.
Yeah, I think so.
Yeah, you need to start over. Not yet. So you first have to download it, and then when you try to open it, it should ask for that.
So just completely uninstall now.
Yeah, uninstall and start over with that.
Individually.
You didn't multiply that. Yeah, that's a high right there. Oh.
So I just type in that right there.
Oh, that's just subtract the area, yeah. Half of.
Alright. Did we turn them
No, sorry. Oh,
Uh-oh. Okay, I put in 0.5 times 19.63 plus, 27.3 times 14.13. And so when I put that much in, I get a number. What does that number represent? Trapezoid. Is that what I want? No. So, but I can keep adjusting this to get the area that I want. But along the way, we've got something useful here. That's just the area of the trapezoid. What will I do now?
Find the area of the circle.
Okay. And then do what? I want to keep it in this line. Subtract. Okay, so it's got a lot of built-in parameters. So if you want pi, just hit pi. And watch what happens. Just type pi, and then boom, it's got it built in. All right, and we don't want to subtract pi, though we want to subtract r squared. And our radius is going to be 14.13. Is that the radius? No. Divided by 2. Now, to square, it's got built-in square and cube by just hitting Shift 2 or Shift 3 will give you those exponents. So you can do Shift 2, and it does it automatically. Any other exponent, you need to hit Shift 6 to do the caret, and then you type in your exponent. But those are built in. Shift 2 and Shift 3 just automatically gives you the square. And now I think, is my equation or expression right? I get 174.75. Someone else get that? Okay. All right, a little more practice at this. Good old quadratics. Okay, how about 84. Now I'm not asking you to type this in, okay? Just hold on a sec. 84x squared plus 3.x minus 51 equals 0. Remember how to solve these? So don't type that in. Don't type that in. We'll talk about x is special, so you don't want to type in x, okay? But just, I'm asking you to solve this. And to solve that, remember what you do? Yeah. Remember what it is? Okay, so there are two solutions. There are two solutions. You can only find one at a time, okay? You're going to find one at a time. So start a new command line and find one of the solutions to this in one, all in one line. Okay? Square root on the Mac is option V, as in Victor. Option V. And on the PC, I think it's Control V to bring up square root. Can you actually?
Yeah.
Yeah, you're not going to.
How do we do square root?
On the Mac, it's Option V. On the PC, it's Control V. Control V. If you want to get the whole thing divided, you can select the whole expression and then hit divide, and so you can select and then hit divide, and it'll give you divide by the whole thing.
Is there an option for
No, that's just saying you have to do one at a time.
Oh, you can't do
Is there any way to like is there another way to insert the square root because I have a tablet and it's I can't press, I can't select control and then
You're going to have to. There's all kinds of commands like that. That'll be a way to do that.
Oh yeah, that's what I was thinking. So can I like divide down the table?
Yeah, just check. There's
Okay.
Show keypad.
Perfect.
Grab square root on it. There's lots of other things. I mean, check, figure out on the, go to Google and say, on such and such pad, because there's all kinds of functions on graphics.
Yeah, I might need, I could.
There you go, that's it. It's giving you.
Highlighting this.
Yeah.
But these are like controls that Windows has.
Oh.
You know, I'll just maybe, for ideal for Google, I'll just maybe search, see if I can find a new
Or your.
general. Okay. I got it.
You got it?
Yeah.
Oh, good.
I was sitting there. Thanks. Yeah.
Oh, you're sorry.
I got 0.756 for one of them. Did you get that? Okay, a couple of ways that you can get the other solution. Any questions about setting that thing up? Is it working for everybody? I'll try to circle around as much as I can to troubleshoot with you guys. Okay, two ways to get the other solution. You can just go in here and edit this one. Just go ahead and edit the one you put. So just do minus. And boom, it just automatically gives you the new value. Okay? Other way you can do this, you can copy and paste expressions. So highlight the whole thing. Copy. Put a new command line and paste. And then change the second one. You can show them both at once. So change that one so one shows plus, the other shows minus. So are these the two solutions you got?
Yep.
Negative 0.802 and 0.756.
How do you do a command line on that?
Command return.
Okay.
Command return.
Yeah. Yeah.
Control E as in Victor.
It shows all these.
Is it something different? Control Shift R. I was giving you wrong information about square root on a PC. Control Shift R gives you square root symbol. What's that? Oh, is it tell you? If you go to the math menu, it gives you it'll give you all the keyboard shortcuts for some of the basic stuff. there's no way I'm going to be able to like go through every single thing with you. So even better than that is if you go to Help and do keyboard shortcuts. And it should come up. This is an exhaustive list of all the keyboard shortcuts for everything. So that's a really helpful menu. Under the Help menu, keyboard shortcuts. Also, under Math, you can show keypad, and that has some things. Some things that are, instead of typing in, they're buttons. Okay, where did that leave off there? Just real good. You guys did that? Okay, just stay on page 1, and we're continuing with the same thing now, but it's calculating mortgage payments, which is a complicated thing. It has lots of stuff involved. When these get to the back, you're going to have to pass left and right. So we're just on page 1. You're not going to type Okay, you're not going to type the formula. Okay, so the ones in the back, could you come over to the wall? Sorry about that. They're coming up. All right, you're not typing the formula in. You're going to continue to work this first page out this way. The formula is similar to me giving you the quadratic formula, but you're going to do this. And so given an interest rate and the cost of the loan, or the home, the principal loan amount, and how many payments, those 3 pieces of information then determine the payment, and that's what you're doing for these different scenarios. So you're practicing using this thing just simply as a calculator. Is the task clear? You're not typing in these letters into Graphic Calculator. You're just using that formula and replicating what we've done so far to find these payments. Okay? Go.
We got the extra.
Yeah. Everyone's got one. Everyone's got one? Notice when you do parentheses, all you have to do is do left parenthesis, and it gives you both. All right? That's convenient. Okay, I'll come around troubleshooting. Grab me if you have a question.
Yeah.
Did it work?
Okay. Yeah, so yeah. Oh, okay, perfect. Let me get a pen.
saving enough decimals. Like, it was only showing you so many. Yeah. I actually never knew that those my math sets were there. I didn't assign those. No, I didn't even know those were there until like end of last week, so I deleted them all. Somehow those automatically got loaded up and I didn't even know. No. I never talked about that.
Because I remember I asked you about the whole Friday, you didn't say anything about it. My math class?
Only the written assignments.
Alright, I got the first three. Wait, yes.
Yeah, this is better. You never go back to anything else after you start with
Okay.
yeah, let me put that up.
You resell that? No. You sell your access code?
I got this.
What's wrong? I'm sure you can. Yeah, you could totally sell it. Because I know my person is the last one.
Okay, so I put the first one and I think the fourth. Is it the fourth one? Yeah, the first one and the fourth one up, so you can check your work. And then a good question came up. So this fourth one, it's actually a $2 billion loan. Okay, pretty nice house. All right, so what would you expect if you were making 120 payments on a $2 billion loan? What would you expect about your payments? They would be large, right? Pretty big, exactly. So that's exactly what's happening here. And so because the payments are so large, it's giving what's called scientific notation. So this E plus 07 means take this first number that you're given times 10 to the 7th. So this is what this means. 1.87 times 10. This is what that means. In other words, take that first number and move the decimal place 7 places to the right. So what is that? Is that 18 million? 18 million? 700,000? Each payment is 18 million.
I mean, is this really a house?
Yeah, so no, probably not. There's probably no $2 billion house yet, probably. But, you know, this is something like our country, right? Our country, we just hit 16 trillion in debt. We just hit 16 trillion in debt. So if we were to calculate what payments would be for 120 months, again, you'd need scientific notation to express that, okay? So that's what that means whenever you see that. Any questions on this first page? Okay, so the software is great. It's doing these values but what about doing each one, typing in all the numbers? That should have felt kind of tedious. Was it tedious? Yeah, but the software is definitely helpful using it this way, but we can do a lot better. So turn the page. So we can use parameters to help us here. Parameters are letters or character strings that we can assign a value to. Okay, now we got to be careful though. If you look up here in that box is telling you these are specific letters that are reserved in Graphing Calculator for special functions. For instance, X and Y. If you ever use the characters X and Y, you are telling Graphing Calculator to graph. Okay, X is reserved for horizontal axis, and Y is reserved for vertical axis. So whenever you put an X or a Y in a command line, Graphing Calculator receives that as, oh, they want me to graph. They want me to graph X and Y. Okay, so You can't, in terms of defining parameters or letters as values, we can't use x and y. Similarly, z, r, t, u, v, etc. So those are the ones that are reserved for special functions, and you can read specifically, and we'll get into those later. But anything else, any other letters, are good for assigning a certain quantity to. Okay? For instance, so new command line, if I just hit capital R, look what happens. It's telling us that that's equal to 1. Why? Because we haven't assigned it anything yet, so graphing calculator just, its default is to assign it as 1. But if I come along and I say it equals 0.0625, now the value of R is 0.0625. Anywhere now in any other command line that we put capital R, it's going to substitute in 0.0625. So there's an example there. So just put in those 3 letters. So anytime you pull up a letter and it says equal 1, that's a free variable that you can use to assign a value to. Okay? So just put those 3 in, R, P, and N, and stop. Okay? Just put R, P, and N and stop. Everybody with me? So just those 3. Now you can also, besides single letters, sometimes it's really convenient to make one of those that's a whole word, because then it's really descriptive as to what you're defining it as. So to do that, everyone with me? You're going to hit backslash, the backward slash, then put in the character string that you want to be one quantity. So we're going to do capital P, M, T. And then backslash again, and the backslashes will disappear. And now you've just turned that character string or that word into a single parameter, a single variable. Does it make sense? Try, so just go down to the next line and just type in a word without doing the backslashes. So always. Okay? What does it think this is now? What is it thinking you're starting to do here? Exactly. Multiply. This is, now it's thinking you're doing A times L times W times A times Y times S. So without those backslashes, it'll stay italicized and thinks that you want to multiply all those things together. With the backslashes, is that the right way? With the backslashes, now I've just made that one value. Okay? Okay, but we want to come back here to the previous, and we want to define what payment is. So we can type in a formula that has R, P, and N in it. So you can type in that formula now. Remember, if the exponent's not a 2 or a 3, you need the caret, so that's shift 6. So now we've just defined this single value payment as a formula involving R, P, and N. So now to get the payment for our current assigned values of R, P, and N, go to a new line and just, you don't need the backslashes now. Once you've defined that character string, from here on out, you can just type in PMT, capital. So just capital PMT, and now it evaluates it. So now it's telling you what the value of that formula is with the current values of R, P, and N. Okay, so think you could make it through that table a little faster now? How do we, all we have to do now to get a new payment is what? Just come up here and change these values, and it'll on the fly then it'll keep updating what the payment is based on your R, P, and N. Okay, so there's a new table. Is that, yeah? So go ahead and work that new. Is it the same values? No, they're different. Some are the same, some are different. So work that table on page 2. Okay, troubles. Who needs help? So you put the backslash. Yeah, what I would do is just delete this line out and then start from the beginning, start from scratch again and see if it works. So start over. That's why it's backslashes will make that TNT1. So we're all set one there, 31 there, whatever it is.
Like it was like 8 o'clock. I was like, alright, I'm gonna do it. I was gonna watch this video real quick. And it was like 1 o'clock. I was like, oh, I should probably do this. But I didn't know how to do this. I was just gonna do this myself. Alright, this is just gonna I started it one day like this one I'm gonna be thinking about that. Brain's supposed to wake me.
Is this a recent thing that came out, or has this been around forever?
Relatively, like, I think it's been around for 5 or 10 years. Like it?
Well, like it a lot better than these graphic calculators.
Yeah, oh yeah.
Here, throw a
Wait
program
till
on
we
that.
start graphing. I mean, the things it can do, like the bars
Yeah.
demonstration, that's all. I built that all on this.
I think one time I tried to put a program in one of those graphic calculators. It took me a couple hours.
Yeah.
That was just like a quadratic formula. It's terrible.
Okay. Still another way to do this, the second way, goes right along with what we were learning last week about function notation, right? So this has the ability to define and use functions. So let's do it that way. So let's come back. What I'm gonna do is I'm just gonna copy that and keep it on the clipboard, but then erase that line. So I'm gonna copy the formula, so I'm gonna type it again. And get rid of all this stuff. Okay, so just like we talked about functions, there's a function name. The most popular name for functions is f. If I just plug f, what does it think f is right now? Yeah, it thinks it's a parameter. And it's because we haven't done anything, it currently has the value of 1. But if we want to make that the name of a function, then what we do here is we want parentheses, right? But we don't want parentheses. You're going to hit Control 9, not Shift 9. So Control 9 also brings up parentheses, but you're invoking this thing to be a function, not multiplication. That's what we want. So now what's going to go inside the parentheses? More generally than x. What is the thing in the parentheses? The function. Input. So you can have one or more inputs. So how many inputs do we have? We have 3. The first we want is r, then p, and then n. Use commas. So whenever we type in f now, its graphing calculator says, oh, okay, I know that that's a function, and I'm gonna need 3 different quantities to evaluate the function. Okay, so now we can put our rule. So it equals, and paste it on there. And we can open a new line. So, and then again, f. Now you still have to do control. Every time you do, you're going to invoke the function f. You need f, then control 9, and do rpn. And why does it give me a value? Yeah, because I have to find. I have to find what rp and n are. So it knows that r is 0.0625, p is 260, n is 360. I could just put values in there. So like that's the first one there. It says 260,000. So what did I just tell graphing calculator? I just told graphing calculator that what? R is 260,000. What does it think that's right there? P. N. Okay, and what did R stand for again? What did it mean? What's the meaning of it? And this is the rate. This is the rate, and this was the loan amount. Okay, so we're telling it that the rate is
260,
and the payment is, or the initial loan.
60 cents.
Yeah, so our loan is 6 cents, and we want 360 payments with a loan of 6 cents and an interest rate of 260,000. Because that's the way we define it. That's the way we told graphing calculator. Okay, so is it right? It's right if that's the scenario. If that's our loan amount and that's our interest rate, then it's right. That's what our payments will be. Fix it. So fix it. Okay. I'll make you laugh. So then on this one, on this table, the answers are already in there. Page 3, so just check, make sure it's working for you. Questions in the middle. I will take it to you if you need me to.
Oh. Yeah. Sorry.
Is it working? Any questions? Okay, I fixed it.
Last year
The original one. The one the example. So in this line, it will override. If you've put in previous values of RPN, in this line, if you're evaluating the function, it's going to take those values. You want to evaluate the function at R equals that, P equals that, N equals that. That's what you'll get in that line. It will ignore that. Even though those are the same. So let me just prove it. questions before we talk about graphing? Or start talking about graphing? Okay, so suppose we want a graph, and we want a graph of different payment amounts depending on how long the loan is. But we want to keep the loan amounts. We know the house we want to buy is $260,000. This is the interest rate they're offering. We want to know how would our payment change for different number of payments for how long we're going to pay this off. Okay, so if we want the payment to be on the y-axis, then what is that relative to the function? Is that input or output? Yeah, output. So if we want to tell it to graph the output of this, we want payment on the y-axis, then we're going to first of all say y equals. Okay? So what it's doing is taking the output of this function and it's setting it equal to y, and that's telling the calculator graph. Graph that payment as output variable on the vertical axis. Now, what we wanted that to be a function of what? We wanted the payment to be dependent on what thing did we say? How many payments, all right? And so we want that to be on the x-axis. So what will we do here? What will we change? What will we make 360? We want that to be on the x-axis. We want that to be variable and shown on the horizontal axis. And for different values of x, we want it to spit out visually what the payment is. So when you do that, hit return. It's graphing it. Okay? How come we don't see anything? Okay, look at what I've got on the x-axis. Up to 13 payments, right? House payments are like, how many payments do you make? Yeah, over several months, like over years, month after month for many, many years. So, for instance, 360 is a typical loan. That's 12 years, right? Or sorry, 30 years. 30-year loan would be 360. So we want to show more of the x-axis, or we want to zoom out. So if you look down here in the lower left-hand corner, you've got your zoom in and out buttons. If you just hit those the way they are now, it'll zoom both axes together, either both in or both out. So if you zoom in, notice they both zoom in together. Okay, so now I'm showing just fractions of values, okay? So I'll zoom back out to where we were before. So what I really want to do is just zoom out, for now, just zoom out on the x-axis so that I'm seeing what? Something like maybe 0 to 500, because we know 360 payments, that's pretty typical. So for a Mac, if you hit Option, notice what happens when you click on Option down here. Now you're just zooming in or out on the horizontal axis. You'll see a horizontal arrows there. So I want to zoom out, that's the first one, on just the horizontal axis so I can see, now I can see 500. What is it on, is it Control? Yeah. To hit the horizontal? So on a PC, if you hit Control, you get that same ability to stretch or shrink the horizontal axis. Okay, similarly vertical axis, on the Mac it's Command, and I think it's Shift on a PC. Do we want to shift, do we want to zoom in or out on the vertical axis? Right now I'm showing 1, 2, 3, 4. And what's the quantity on my vertical axis? What's the amount?
The payment amount.
The payment. Do I want to zoom in or out if I'm showing 1 through 4 right now? Out. My payment's going to be like 1,000 or 2,000 or something like that. So I want to shift out. So, or zoom out, sorry. And when we get to 1,000 or 2,000, we should start to see something. Does this graph make sense? Does it make sense that it's decreasing and why? Why would that make sense that this graph is going down?
Because you're paying off the interest rate at first and then it goes to principal?
What are the quantities we're graphing? We lost track of the quantities. What are the quantities on the x and y axis? What is x axis?
Time.
It's not really the time in months. What is that x-axis? Yeah.
The less payments that you pay, the bigger your payments have to be.
Yeah, this x-axis is the total number of payments in the loan. It's not. This isn't time going by. This is a whole bunch of different loans with different numbers of payments. So if we choose to pay it off in less payments, then what about those payments? Higher. And if we choose to pay it off in more payments, then each payment will be lower. Okay, that's what this is. Notice that I'm seeing some of the this graph down here in the third quadrant. Make sense? What would it mean down here? What are the values of my quantities over there? Number of payments over here is negative. My payment amount is
Negative.
yeah, that's the bank paying you. That'd be a nice deal. Not realistic though. So what we want to do is we don't want that. So you can if you move your cursor to the origin, you can just click and drag it, move it however you want. So we don't want that part of the graph because it doesn't make sense. What makes sense is starting at 0 payments on. So if we go back to the command line and you hit comma, define x how you want it. So 0 less than x less than 500. So this is only it's only gonna graph it when x is from 0 to 500. So now that thing's gone, so now we have what we want. Okay, everyone able to get this? Yes, ma'am.
How do you do the y-axis? I can't figure that out.
It's
Like zoom out.
command. You
Oh,
hold the
command.
command button, and then you should see
I
it up and down. Okay, other questions? Yes, ma'am. The graph? I'm not sure what that is. You can change the color of the graph by clicking and holding on the square, and you get different color choices. I'll come take a look at that. Yeah?
I don't know why, but when I push my comma button, it starts with
I have no idea what that is. All right.
I wanted to get them out during the summer, but they're not bothering me. Well, I was like doing research on this. To be more honest.
Okay, hold on a second. One more thing I want to show you. If you go to the graph and just click on the graph, you get crosshairs. Okay? And you can now drag those, and as you drag those up here in the upper left, it shows you values of x and the corresponding y. Okay? So you can just drag it, and it'll wherever you stop, it'll tell you. Right now, I'm talking about 174 payments. My payment amount would be $22.77.
How'd you do that?
Just take your cursor and just click on the graph. The crosshair should appear, and then you can just drag the crosshair on the graph, and it gives you ordered pairs. Okay, for Friday's homework, those of you who have a laptop, so this is what it says at the end of the homework. So there's 3 files that I want you to create and save on your computer. After doing that, if you have it on your laptop, I'm just going to come around and do a check in class on Friday. I'll put you to work, and then I'll come around and do a check. If you have graphing calculator on a home computer, you don't have a laptop that you're bringing, I'm going to send an email out. You're going to reply once with all 3 of those files attached to the email before 9 a.m. Okay? Is it fair? Does it make sense?
Are these files on Blackboard?
What's that?
Are these files on
Yeah,
Blackboard?
this is the end of the assignment. The assignment will be in the normal place assignment area. And don't throw away that homework that you did for today. I will collect that eventually. Yes?
So we do have homework on math class, you will tell us?
What's that?
We,
Yeah. There's nothing. You can totally ignore my math lab for now. I realized at the end of last week that they were automatically putting assignments up. I didn't do that. So I deleted all the assignments. No my math lab. Just written assignments for now. Yeah. If you need help, I can help you.
I did the homework and I emailed like during the homework I emailed like why is it's like really not is there a point to it? And like because like